Hello Pre-AP Geometry students. This video contains your 3.6 lesson, Lines in the Coordinate Plane. Couple things before we get started. We are going to flip this lesson, which means you're going to learn it completely at home. This entire lesson will be taught in this video, and then instead of doing the homework at home, we'll be doing the homework in class. So if you don't have your note packets open to 3.6, you might want to pause the video right now, get your notes out, and open it to your 3.6 notes. Since this is a video, I will be moving quickly, more quickly than I do in class, trying to keep the video a little bit shorter. So remember, you can stop and pause and rewind anytime you need to, and replay things if you need to see them again. Also, if you have a question and you can't figure it out from the video, be sure and stop the video, take a minute, and write your question down in the margin, because likely you'll forget that question if you don't write it down, and if you've written it down, you can ask me when you see me in class next time. All right, so we're going to start with two of three forms of a linear equation that we'll be studying today. These should seem familiar to you from Algebra 1. The first one is the slope-intercept form of a linear equation that looks like this. Y is equal to mx plus b. Remember that when an equation is written in this form, solve for y. M, the coefficient of x, is your slope, and b, this constant term, is your y-intercept, where the line crosses the y-axis. All right, the other form of a linear equation that we're going to talk about right now is called point-slope form. The equation looks like this. Y minus y sub 1 is equal to the slope times x minus x sub 1. Remember, x sub 1 and y sub 1 are forms of, x sub 1 and y sub 1 are specific points that lie on the line. Okay, these subscripts allow us to differentiate between x and y in general. All right, x sub 1 and y sub 1 are specific points that lie on the line. Okay, so let's take a look at the equation, or the examples, and see if we can, for each of these, write the equation in this form, in slope-intercept form. So our final answers should look like this. All right, number 1 says the slope of a line is 6, so we're given the slope, and it passes through the point 3, negative 4. So if I have a point that lies on the line and the slope of the line, point, slope, you should be thinking, I'm going to use point-slope form of linear equation. By the way, I like to call this point-slope form of a linear equation your best friend, because if you know this form of a linear equation, you'll be able to solve any of these problems. All right, so let's start by writing down that equation in general form. Y minus y sub 1 is equal to the slope times x minus x sub 1. All right, oh, sorry, let me fix that real quick. Let me make that look more like a subscript. All right, so what we're going to do is go back and plug these numbers into the equation. So it would be y minus the y value of my point. Well, I'm going to be subtracting a negative 4. And remember, subtracting a negative 4 is the same thing as adding a positive 4. So I'm actually going to write y plus 4 is equal to our slope of 6, start some parentheses, times x in general minus the x value of the specific point, which is 3. All right, so once you have that written, then just a little bit of algebra, a couple steps to get it in this slope-intercept form. So I'm going to start by distributing on the right and getting rid of those parentheses. So rewrite the left side as is. Y plus 4 is equal to, let's distribute on the right, and we get 6x minus 18. And then our last step, see if I can squeeze it in here to get the y by itself. We're going to subtract 4 from both sides. So our final answer then is y is equal to 6x minus 22. All right, let's move on to example 2. It says we have a line that passes through these 2 points, 1, negative 3, and 0, 3, and we're asked to write the equation of that line in slope-intercept form. Okay, so we're going to have to do a little more work than we did on the last problem, because this time we don't have a slope, okay? We're going to have to find a slope to put in for m. So over here in the margin, I'm going to remind us of our slope formula. Since we're given 2 points that lie on the line, we can use the slope formula to find the slope. Slope, remember, is a ratio of a vertical change to a horizontal change. You find that vertical change by taking, oh, what in the world did I just do? Let me undo that. Sorry about that. Here we go. All right, it's a ratio of the vertical change to a horizontal change. You find the vertical change by subtracting y values. You find the horizontal change by subtracting x values. All right, so let's find our slope first of all. Our slope will be, in the numerator of this ratio, I'm going to take the difference in y values, the second y value minus the first y value. So that would be 3 minus a negative 3, which is the same as 3 plus 3. And then in the denominator, we're going to take the difference of the x values, so that would be 0 minus 1. All right, and then a little bit of arithmetic. 3 plus 3 is 6. 0 minus 1 is negative 1, so our slope is negative 6. All right, so I have a slope to put in for m. Now, for x1, y1, I can choose either one of these equations. It doesn't matter which one. You'll get the same answer in the end, no matter which equation you choose. So I'm just going to choose the second one because it has no negatives, and that 0 will make things easier. And I'm going to plug the coordinates of that point and the slope that we just found out into this equation. X minus x sub 1 is equal to the slope, y minus y sub 1 is equal to the slope times x minus x sub 1. All right, so that would be, since I'm using this point for my x1, y1, it would be y minus 3 is equal to that slope of negative 6 that we just found, times x minus the x value of our point, which is just 0. Well, this is nice because x minus 0 is just going to be x, isn't it? All right, so that's going to help us get it in slope-intercept form a little bit more quickly. X minus 0 is just x. Negative 6 times x is negative 6x. So one more step to get this in slope-intercept form, we're going to add 3 to both sides. So our final answer is y equals negative 6x plus 3. All right, moving on to number 3. This time we're given the x-intercept and the y-intercept of the line, and we're asked to write the equation of the line in slope-intercept form. So we could do exactly what we did in example 2. Find the slope and then pick one of these points and plug it into point-slope form. But I think I see a shortcut here since we know the y-intercept. Since we know the y-intercept, we're told that it's 0, 3, we know what b is. B is going to be 3. Okay, so the only other thing we need to put the equation in this form is to find the slope. So let's use our slope formula and find out what the slope of this line is. So difference in y is on top. That would be 3 minus 0 on top. And then on the bottom, difference in x's, 0 minus 5. That would give me 3 over negative 5. So the slope of this line is negative 3/5. All right, so we have our b. Okay, we were given that. We just figured out the slope. Now let's plug it into this y equals mx plus b form. The final answer would be y equals negative 3/5 x and then plus 3. All right. The next thing we're going to do is practice graphing some lines from the equations of lines. All right, so let's take a look at this first line we're being asked to graph. It says graph and label these lines on the set of axes. Okay, line L has this equation. Notice this equation is in slope-intercept form. So this is my slope. This is the y-intercept. Let's start with the y-intercept of positive 4. So that means that this line will cross the y-axis at positive 4. And then remember, slope is rise over run, which is a vertical change followed by a horizontal change. In this case, they're both positive. So from this y-intercept, I'm going to make a vertical change of positive 1 and a horizontal change of positive 1, 2, 3, and put another point. Okay? I could do that again. I could go up 1 and 1, 2, 3 to the right. Also, since 1 over 3 is the same thing as negative 1 over negative 3, I could go down 1 and left 3 and be on the line. All right, so get 2 or 3 points. Of course, the minimum number of points you need is 2. but a few more will help you get a straight line. Now, I highly recommend you grab a straight edge and draw your line. Just a warning ahead of time, I don't have a straight edge on this air slate, so I'm going to do the best I can to get a straight line, and that one is not too bad. All right. All right, and the directions said to graph and label these lines, so this is our line L. Okay, line M. Notice this is not in slope-intercept form, but it should look familiar to you. This is actually in point-slope form. Y minus a y sub value equal to our slope of -1 times x minus the x sub value. Okay, so that means that this line has a slope of -1, and it passes through the point. X1 would be 3, okay, and then since this says y plus 2, that's the same thing as y minus -2, so the y value of that point would be 2. All right, so let's plot this point, 3, -2. I'm going to go to the right, 1, 2, 3, and down 2, okay, and then use my slope of -1. Now, -1 is the same thing as either -1 over +1 or +1 over -1. So from this point, I can either go down 1 and right 1, or I could go up 1 and left 1 to get a couple more points that lie on that line. All right, I'm going to change colors real quick and graph this line in a different color. All right, so again, warning, this is probably not going to be a very, let me try it from this direction. Very straight line. Oh, so please use a straight edge on your paper and you'll have a much better looking line than I just drew. Okay, we were asked to label the line. This is line M, so we're going to call that line M. All right, next line. You'll notice that its equation is line N, y equals -3. All right, now what does a line that looks like, that has this equation look like? Well, I just want to remind you of the mnemonic device HOY, which isn't a word. It just helps us to remember that horizontal lines have 0 slope and their equations are y equals a constant. So this is going to be a horizontal line. If y equals -3, that means that it goes through -3 on the x-axis. So I'm going to draw a straight line through -3 on the x-axis, and that is our line N. So let's label that line. All right. And then last but not least, let me see. Let's change green. All right. Line P. It is x equals -1. X equals a constant. So just a little reminder of VUX, which again is not a word. It just is a little mnemonic device to help you remember that vertical lines have undefined slopes and their equations are x equals a constant. So I'm going to go through -1 on the x-axis, draw a straight line through -1 on the x-axis, and there's our line x equals -1. The name of that line is P, so let's label it. All right, so that was graphing lines. Let's move on and talk about the third form of a linear equation that we'll study today, and that is standard form of a linear equation. It looks like this. Capital A times x plus capital B times y is equal to capital C, where A is your coefficient of x, B is the coefficient of y, and C is your constant term. Okay, let's take this linear equation, ax plus by equals c, and let's solve it for y. All right, to solve for y, that means I'm going to get the y all by itself on one side of the equal sign. So we'll start by getting rid of this ax term. Since it's being added to by, we'll subtract it from both sides. And we get, when these ax's cancel, we get b times y on the left side of the equal sign is equal to -ax plus c. These are unlike terms. I cannot combine them into one term. And then to continue solving for y isn't by itself yet. It's being multiplied by b. So to undo that multiplication, we're going to divide everything by b. All right. And when we do, we get y equals the opposite of a divided by b times x plus c divided by b. All right. Now, does this look familiar to you? It should. It should look like the slope-intercept form of a linear equation. Y equals mx plus b. Okay, so in other words, let's go over here, learn this helpful hint. When you have an equation in standard form, ax plus by equals c, we can quickly find the slope and y-intercept by, to find the slope, I'm going to take the opposite of a over b, and to find the y-intercept, okay, I'm going to take c over b. All right, so if an equation is written in standard form, you can find its slope quickly by taking the opposite of a divided by b, and you can find the y-intercept by taking c divided by b. Now, if you want, you can always take an equation in standard form and solve it for y, get it in this form, and get the same information that we would from this little arithmetic. But since every time you solve for y, the same thing always happens. The coefficient of x is always the opposite of a over b, and the constant term is always c over b. Instead of doing all this algebra every time, just memorize this, do a little bit of arithmetic, and you'll know your slope and your y-intercept quickly from an equation in standard form. All right, moving on to page 2. Let's use that information to work these examples. Okay, notice all of these equations are all in standard form. They're all ax, they all look like this. Ax plus b, oh, what in the world have I just done? Sorry, here, let me start this over. Okay, they all look like ax plus by is equal to c. They're all in standard form. So what we just learned is that when an equation is in standard form, we can find the slope quickly by taking the opposite of a divided by b, and we can find the y-intercept by taking c divided by b, where a is your coefficient on x, b is the coefficient of y, and c is your constant term. So let's use this information, slopes and y-intercepts if necessary, to determine if these pairs of lines are parallel, perpendicular, intersecting, or coinciding. Now, we talked about these three things yesterday, three relationships between two lines in the 3.5 lesson. We didn't mention coinciding, so let me just mention very quickly, if two lines are coinciding, that just means they're the same line. We have one line graphically that lies right on top of another line, okay? Oh, sorry, pretend like that yellow line is laying exactly on top of the red line. What that means graphically is that they share every point, right? Algebraically, what that means is every ordered pair that satisfies one equation will satisfy the other equation. All right, so we can determine what relationship these pairs of lines have simply by looking at their slopes and, if necessary, their y-intercepts. So let's take a look at example 1. The first line, we're going to find the slope by taking the opposite of a over b. A is 3, positive 3, so its opposite will be negative 3. Okay, b, the coefficient of y, is 5, so the slope of the first line is negative 3/5. Now let's compare that to the slope of the second line. So we're going to take, again, the opposite of a over b. A is 3 again, so its opposite is negative 3. B is positive 3. And negative 3 divided by positive 3 is negative 1. All right, so compare these slopes. These slopes are different. If two lines have different slopes, that means at some point they're going to intersect. And remember, one of our first postulates we learned says, if two lines intersect, they're going to intersect in exactly one point. So this pair of equations would have one solution, and that is because the two graphs are intersecting. Intersecting. All right, let's take a look at example number 2. We're going to begin again by looking at the slopes of each line. So the slope of the first line we're going to find by taking the opposite of a over b. A in this case is negative 3. Now what's the opposite of negative 3? That would be positive 3. Let's put that over b, the coefficient of y, and the slope of our first line is positive 3/5. The slope of the second line, let's take the opposite of a over b. The opposite of negative 6 is positive 6. And then b, our coefficient of y, is 10. 6/10 reduces to 3/5. So notice that these two lines have the same slope. All right, if they have the same slope, we know that they are either parallel or they could be coinciding. They could actually be the same line. So we can't stop here. We have to investigate further. Let's go ahead and look at their y-intercepts and see if we can figure out what's going on. All right, so the y-intercept of the first line would be c over b, the constant over the coefficient of y, in this case 4 over 5. Okay, the y-intercept of the second line would be 8 over 10, and 8 over 10 reduces to 4/5. All right, so look what we have going on. Same slope, same y-intercept. These two lines, these two equations are actually the equation of the same line, so we say that these two lines are coinciding. All right. All right, example 3. Again, we're going to start by looking at the slope. Let's take the opposite of a over b. Now, a is invisible, but it's here. It's a -1, right? And the opposite of -1 is +1. All right, let's put that over b, which is 2. So the slope of the first line is 1/2. The slope of the second line, opposite of a over b, that would be -3 over 6, which reduces to, oh, whoops, I'm so sorry. The opposite of -3 is +3. And +3/6 reduces to 1/2. So again, we have the same slope. But we have to keep going. We don't know yet whether these two lines are parallel or coinciding. We'll know by looking at their y-intercepts. So let's do that real quick. Find the y-intercept by taking the constant over b, which is a coefficient of y. In this case, -6 over 2. -6 divided by 2 is -3. And then the second line, let's look at its y-intercept. So we're going to take c over b, which would be 18 divided by 6. And 18 divided by 6 is +3. So these two lines have the same slope, but different y-intercepts. What that tells us is that those two lines are parallel. All right, if they're parallel, that means they'll never intersect, so this system of equations has no solution. There is no ordered pair that satisfies both of these equations at the same time. All right, and then I bet you can guess what's going to happen in number 4, but let's show it algebraically. Let's find the slope by taking the opposite of a over b. A is -4, so its opposite is +4. B is 3. The slope of the second line is opposite of a, that's -3 in this case. Remember, the opposite of +3 is -3 over 4. All right, now take a look at these two numbers, these two slopes. 4/3 and -3/4 are opposite reciprocals, aren't they? If we were to multiply them together, we would get a product of +1 because they are opposite reciprocals. And remember, we learned in our 3.5 lesson that if the slopes of two lines are opposite reciprocals, then those two lines are perpendicular. Oops, sorry about that. Oh. Okay, let's work one more example together. This one says, find the equations of the lines parallel and perpendicular to this line and passing through the point 1, 4. All right, so this is a two-part problem. We're going to first find the equation of the line, and we're going to find this equation in slope-intercept form that's parallel to this line. Okay, now remember in our last lesson we learned that if two lines are parallel, they have the same slope. So let's start by finding out what the slope of this line is. The slope of this line would be opposite of a over b, so that would be +3, because the opposite of -3 over, the opposite of -3 is +1, and we divide that by b, which is invisible, but it's there, it's 1. So the slope of this line, the line that we're given, is 3. So any parallel slope, or in other words, the slope of any line parallel to that, would also be 3. Okay, so we have our slope of 3. Okay, we have an x1, y1, because we're given the coordinates of a point that lie on that line. So let's take that information and plug it into our point slope form. Y minus y sub 1 is equal to the slope times x minus x sub 1. All right, so in this case, it would be y minus, now I'm subtracting the y value of my point, so that would be y minus 4 is equal to that parallel slope of 3 times x minus the x value of our point, which is 1. All right, so now just a little bit of algebra to get it into slope-intercept form. On the right side, I'm going to distribute and get rid of those parentheses, so I'd have 3x minus 3. And then one more step, add 4 to both sides. And our final answer then would be y equals 3x plus 1. All right, that would be the equation of the line that is parallel to this line and passes through the point 1, 4. All right, so now let's find the equation of the line that passes through that same point and is perpendicular to our given line. Okay, so now let's go back to the line we were given. Its slope, remember, was positive 3. So a perpendicular slope, or the slope of a line perpendicular to that, would be the opposite reciprocal. Remember, 3 is the same thing as 3 over 1, so its opposite reciprocal would be negative 1/3. Remember, you do two things. You take the reciprocal, you flip the fraction over, and you change the sign. So there's our perpendicular slope. We're going to use the same x1, y1 and plug it into our point slope form. Y minus y sub 1 is equal to the slope times x minus x sub 1. All right, so that would be y minus 4 again is equal to, this time we're going to use that perpendicular slope of negative 1/3 times x minus x sub 1. Okay. Oh, I know what x sub 1 is. What am I doing? Sorry about that. Let me fix that. Okay, x sub 1 is 1. All right, let's distribute on the right and get rid of those parentheses. So y minus 4 is equal to negative 1/3 x. And then we're going to take a negative 1/3 times a negative 1. And negative times a negative is a positive, so that would be positive 1/3. All right, and then to solve for y, we're going to get the y by itself. We're going to add 4 to both sides. I need to add 4 to 1/3. So remember, 4 is the same as 12/3, right? So I'm going to take, instead of writing 4, I'm going to add 12/3 to this right side. And when we do, we get our final answer of y is equal to negative 1/3 x plus 1/3 plus 12 more thirds would be 13/3. All right, so final answer is y equals negative 1/3 x plus 13/3. All right, if you have any questions, be sure and write them down. Ask me when you see me again in class, and we will be doing the homework for this lesson in class when I see you next time.